Before you start this lesson, please make sure you've got a piece of paper and a pen to make notes and complete tasks. Today you're going to be looking at the properties of hydrocarbons, and by the end of this lesson you will be able to compare the properties of different hydrocarbons. Now before we get started, I want you to have a little go at predicting the properties of alkanes. So pause the video and answer the questions below in your notes. Great, you've had a go. We'll look at the answers later in the lesson. The main use of alkanes from crude oil is as fuels. Alkanes are good fuels because they release a lot of energy when they burn. The properties of alkanes depend on the size of the molecule, and this affects their use as fuels. Here you've got 5 different examples. And as you go from bitumen to petrol, the size of the molecules decreases. As you can see, their colour also changes. Bitumen is very black, and then as you move down, the colours get lighter until you get to petrol, which is colourless. Here we've got a summary slide of the different properties of small and big alkanes. There's a couple of new words on this slide, so I'm just going to go through the meaning of those for you. On the second arrow down, you've got the word viscosity. Now, the viscosity of a liquid is how easily it flows. A runny liquid has a low viscosity, while a thick, slow-moving liquid, for example syrup, has a high viscosity. On the third arrow down, we've got the word flammability. Now, the flammability of a fuel is how easily it catches fire. A flammable fuel catches fire easily. So let's compare the two. First of all, we'll look at boiling point. Now, small alkanes have a very low boiling point. Think about methane. That's a gas at room temperature. Whereas big alkanes have a very high boiling point, so they are commonly liquids at room temperature. When we think about viscosity, small alkanes are very runny, whereas big alkanes are very viscous, so they are thick and syrupy. When looking at flammability, so the ease at which the alkane will catch fire, small alkanes ignite very easily, whereas big alkanes are harder to ignite. They will all still burn though, it's just how hard it is to start the combustion process. When they are burning, small alkanes burn with a clean flame, whereas as the chain length of the alkane increases, the flames get dirtier. So big alkanes burn with a smoky flame or a very sooty flame. Now it's important that you know the differences between the two. So please pause the video and copy this information into your notes. Great, thanks for doing that. Now before we move on, it's important that you note that shorter alkanes are more in demand as fuels because they flow easily, they're more flammable, and they burn with a cleaner flame. Although larger alkanes are less easy to use, some are used in fuels. For example, fuel oil is used in ships and in some central heating systems. What I'd like you to do is practice the information you've learnt in today's video. So pause the video and have a go at answering these questions on the properties of hydrocarbons, and then come back for the answers. Okay, great. Thanks for having a go. So question 1 is asking you, crude oil is a mixture of hydrocarbons. State what are hydrocarbons. Now hopefully your answer says something like compounds that contain hydrogen and carbon only. The second question asks you, the hydrocarbons in crude oil have different properties. Explain which of these properties does separation by fractional distillation depend on and why. Now hopefully you've remembered that fractional distillation heats the crude oil so it evaporates, and therefore we're using the different boiling points of each fraction to separate them out. Question 3 asks you about kerosene. Now this is a fraction in crude oil used for aeroplanes. Is kerosene a pure substance or a mixture? Explain your answers. Now thinking back again to fractional distillation, the fractions come off on a range of boiling points. So this means you've got a mixture. Only pure substance, if it was a pure substance, it would have a specific boiling point of one temperature rather than a range. So your answer needs to say something like, a mixture as the fraction boils over a range of temperatures rather than one specific temperature. Okay, back to the question I gave you at the beginning. Pause the video and have a go at re-answering this question. Would you change any of your answers? Come back when you've finished and we'll go through it together. Right, you've had a go. Let's look at the answers and see how you did. So hopefully you've got that the highest boiling point will be decane because it's the longer chain, it's the bigger alkane. The most viscous is also decane, again because it's a bigger alkane. Methane would be the easiest to burn because it is a small alkane. Burns with the dirtiest flame, i.e. lots of soot, again that would be decane because it's a big alkane. If you found this set of questions quite difficult or most of your answers are wrong, I'd recommend that you go back and recap that table of properties that we did earlier in the video. Time for a bit of a quiz. Write down each of your answers for the questions and then the answers will come at the end. Question 1. Crude oil can be separated into different A. frictions, B. fractions, or C. functions. Question 2. A fractional distillation column separates oil fractions based on their A. boiling points, B. melting points, or C. flammability. Question 3. Which fraction is collected at the top of a fractionating column? Is it A. gas, B. kerosene, or C. bitumen? Question 4. As the carbon chain length increases, the flammability, i.e. how easily it catches fire, does it increase or decrease? Question 5. As the carbon chain length increases, the viscosity, or thickness, does it increase or decrease? Here are the answers. Question 1, the answer, crude oil can be separated into different fractions. Question 2, a fractional distillation column separates oil fractions based on their boiling points. Question 3, which fraction is collected at the top of the column? That's gas. As the carbon chain length increases, the flammability decreases. And as the carbon chain length increases, the viscosity increases. How did you do? If you've not done very well, it's not a problem. Just go back, review your notes on this, maybe look in your revision guide and do a few more practice questions from there.